everyone, and welcome to the HP Indigo V12 Lab. Before we will start our journey, let's first describe what is the V12. Well, the V12 is an Indigo with the Indigo print quality and versatility, but now running in the speed of 400 feet per minute. It's 120 meters per minute. And it will bring us to the next phase. We call it an Indigo First. Indigo First means that our customer will be able to put any job, regardless in the job size, on the Indigo. If today, for example, we represent about 10 to 20% of the volume on a given site, with the V12 working side by side with the rest of our portfolio, we will be able to print about 70% of the volume. This is the Indigo First. Now let's start our journey.
Let's start our tour at the Alpha Lab. Alpha is where we test the press just before we send it to the customer. It's a transition between the R&D and the mode of operation in the field. We are testing the equipment in all modes of operation, from the versatility of the application, the media, the inks, and all the mode of operation the customer eventually will use.
We basically try to mimic production environment, meaning substrate changeovers, different inks, different applications, to try to test it in a real-time production as close as possible before we send it to the first customers. So let's see the rest of the lab.
We are at the heart of the R&D lab. This is where we test, we integrate, and we develop everything that related to the press. We have 4 LP presses. LP means lab prototype.
What do you need 4 presses? What is the role of each and every press?
Let's start walking and I'll show you around. This is the first press. This is where we test all the software capabilities, all the features, make sure there are no bugs and everything works smoothly together. We'll go to the next press. This is, as you can see, we took apart the press and we rebuild it based on the final configuration, and this is what we're going to send to the customer. We are building everything from scratch, make sure that everything fits together. The third press is where we test the subsystem. We take the press, separate it to about 80 subsystems. Subsystem mean unwinder, rewinder, cleaning station, charge roller. Each of the components is being tested by itself as a unit test, and then combine everything together to test it on a press. Now let's go to the last press and I'll show you the system press. So this is the 4th press. We call it system test. This is where all subsystems combine together. We take the hardware, the software, the media, the different kind of ink, and we test the application. We test how the customer eventually going to use the press, make sure that everything works together as a whole.
Roy, thank you very much for the tour.
You're welcome.
Before we will see the press in action, we will see it printing in the speed of 120 meters per minute, we would like to highlight the technology behind the V12. We call it LEPx. Let's see how it works. Hi, Moti.
Hi, Elad.
Well, Moti is the head of the V12 system engineering. When we designed the V12, we tried to keep as many components as possible similar to our current technology. For example, the inks and the ink stations. While others needed to be modified in order to meet the V12 strategic intent, which is replaced at least 2 flexos. So Moti, please take us through the recent modifications.
Well, the first component that we had to modify is the printing plate, the digital plate. This is the current plate that we use on the current presses, that we call it PIP, the PIP foil. So we had to replace it with much more robust component. So you can see it here. This is this aluminum cylinder. We call it ACID. ACID stands for amorphous silicon drum, and its lifespan is 70 times higher than the current PIP.
What is the expected replacement frequency of this ACID?
Well, with this high lifespan, the replacement rate of this component will be once a month.
Okay, what's next?
The second component is the printing blanket. This is the current printing blanket that we use in our current presses. It's about 1 meter long, but we have to replace it with the new blanket, much more robust and much more longer because of the new architecture of the press. This is the new blanket. It's about 6 meters long, and its lifespan is about 16 times more than the current blanket.
Okay, so 16 times longer, which means about a blanket replacement every week.
Once a week.
And the length of the blanket will allow superior frame utilization.
Exactly. Frame utilization is much better That way we improve productivity.
And last, Moti, the writing head.
Yes, this is the current writing head that we use in our current presses. It's based on laser technology, rotating mirrors, and series of lenses. Now we had to put 6 of those in the press. So we had to design a new one, which should be much smaller. So this is the new writing head. You can see much smaller, about 10 times smaller than the current one. It's based on LED technology. There is an array here of about 21,000 LEDs.
Okay. And what about the resolution of this new writing head?
The resolution is 1600 native DPI.
So 10 times smaller and
Yes.
double the resolution.
Double the resolution and no moving parts.
Nice. Okay, so this was the new process element that we needed to redesign for the V12. I think it's time to see the press running. Like any other Indigo, the V12 also goes from right to left. So let's start with the unwinder. We will also offer butt splicer and Turret winder as an options to increase productivity. From the unwinder, the web is moving to the inline priming unit, the ILP. And from the ILP, the web is moving to the buffer station, which is supposed to synchronize between the web motion to the speed of the engine. So the web is moving all the way through the buffer station into the impression drum, where the image is transferred from the blanket to the web. And then the web is going to a series of, let's say, array of sensors and cameras. We have the ILS, the inline scanner. It's a high-resolution camera that constantly takes images of the labels. And we have the spectrophotometer that measures the optical properties of the labels. And we have other cameras and sensors to measure the registration and the scaling. The purpose of this entire array is to provide the digital assurance to the operator that he is printing high-level, high-quality sellable material. When the web is moving 400 feet per minute, it's 120 meters per minute, it's very difficult for the human eye to follow and track defects. So we need to provide the assurance to the operator and to identify the defects in order to maintain high yields. Now let's go to the second cart of the V12, which is the heart of the press. This is the print engine. Well, the print engine of the V12 is combined with 6 sub-engines. 1, 2, 3, 4, 5, and 6. Each of them with a cleaning station, a charge roller, a writing head, and 2 ink stations. Altogether, 12 different inks. It's very rare that you will require 12 different inks on the same label, but by having 12 inks on the V12 provide a lot of productivity. You will hardly never have to waste time to do ink changeovers. You will have your 12 most common inks already pre-installed on the press. So with a single rotation of the blanket, going all through the 6 engines, you can collect up to 6 inks and still maintain the speed of 120 meters per minute. If for some reason you will require more than 6 inks, you need to go to the far ends of the Pantone, combine security features with CMYK OVG or silver inks, etc. It's not a problem. You simply need to go to a second rotation of the blanket and collect the additional colors between 7 to 12 altogether. And then the speed of the press will be cut by half, so it's 60 meters per minute, 200 feet per minute. So now let's move to the third cart of the press, the UIC, the Utility Ink Cabinet. The user experience in the V12 is a critical element to support the productivity of the press. We took this approach along the entire press. For example, in the UIC, the Utility Ink Cabinet, if you will take a look here in the white tubes, you can see one in the back and one in the front. The purpose here is whenever a tube will be running out of ink, we have a mechanism called revolver that will automatically switch between the empty tube to a fresh tube. So the operator will not have to pay attention every second if the press is running out of ink or not. The press will run constantly. We took this approach along the entire press. For example, a frontal approach. 95% of the activities involved with the V12 maintenance can be done from the front side of the press. So the operator will hardly ever need to go back and forth from the rear side of the press to the front side of the press. Additional elements are the screens. We have a screen, an indicator screen for each and every ink. In addition, we will have a control unit in the middle of the press and the beginning of the press. So the operator will be able to control the V12 basically wherever he will stand without the need to go back and forth to the end of the press and to where he's doing this maintenance. Now let's go and see the operator station. Hello, Ronen.
Hey, Elad.
Ronen is the head of the Indigo user experience team. Ronen, please take us through the user experience of the operator station.
So first of all, I'd like to tell you that the operator station user experience was defined and designed with the help of our customers. We brought customers from all over the globe to come here and actually help us define what needs to be shown on the operator console. The operator console is divided into three main sections. The first one is the queue management. The queue management allows full optimization of the jobs and the job basket that the customer has, moving forward job, moving backwards, printing, putting on hold, etc., etc. The second part on the right-hand side is actually being used to monitor the press health. Everything, every little thing that the press will have will indicate it here, whether the ink is almost done, whether needs to be changes something, consumable replacements, etc. Everything is being shown here in real time. The third part is actually managing and seeing the print quality of the job that I'm currently printing, and it will be shown here constantly. So I'll be able to see whether there are defects or something like that. Everything being done here via our ILS system, inline scanner.
So basically we have three levels of indication. The job level, to make sure that we are printing sellable labels.
Exactly.
And then we have the production floor optimization and the mechanical status of the press.
Precisely, Elad.
Okay, guys, would you like to see an Indigo running in the speed of 400 feet per minute? With the V12 on the production floor, our goal is that most of the volume will be printed on an Indigo. Indigo will be the default. We call it Indigo first. Flexo will play a role in the ultra long jobs or the very simple jobs or specialty lines. It was a pleasure having you here in the V12 lab. We can't wait to you guys to visit us and see this beast in action. See you guys.